Let x and y be two jointly continuous random variables with joint PDF fxy equal to if y plus x less than or equal 1 and x and y are greater than 0. Otherwise, it is 0. So asking to find covariance xy. Covariance xy. First, we will write the equation for the covariance xy. What is the equation for the covariance xy? Expected value of xy minus expected value of x times expected value of y. Now we should find this expected value of xy, expected value of x, and expected value of y separately and plug those numbers to this equation. Alright, before we do that, I should consider the region. So we know y plus x less than or equal 1 and x and y greater than or equal 0. So what is the region we should consider for this? Yes, let me draw this x and y coordinate system. This is x and y. So you see x, y greater than 0, x greater than 0, y greater than 0. Therefore, we should consider this area, whole area. But we have another inequality. What is that? Y plus x less than or equal 1. So we should consider the inequality 2. Y plus x less than or equal 1. I write down this as an equation. Y equal minus x plus 1. Now I draw this line on this coordinate system. So this should be 1, this should be 1. Next step to select the region. You know we have two regions. One is above the green line, other one is below the green line, which is this triangle. So which region that satisfies this inequality? So we know the region below the green line. First, we will find the expected value of x. How do we find the expected value of x? Integrals negative infinity to positive infinity x fxx marginal of x dx. So we have joint density function. Therefore, we can write this negative infinity. We can write down fxx negative infinity to positive infinity fxy dy. So that is the fxx then dx. Now we can write down expected value of x equal negative infinity to positive infinity x fxy dy dx. So now let me go back to our problem. X fxy, in our case it is 2, so x times 2 2x dy dx. Now we need to decide the limits of y and x. Go back to the diagram here. You see y goes from here to here because we should consider only this region. So now you know y goes from here to here and start from 0 and stop on this line, which is y equal negative x plus 1. So the limit of y is then from 0 to 1 minus x. And x value, yes, we see x value is going from 0 to here. If you draw the line again like this, but we use this restriction when we use y. Therefore, We consider the minimum value of x, which is 0, and maximum value of x, which is 1. So x goes from 0 to 1. So once you integrate this one, expected value of x should be 1/3. Then expected value of y. Do you think we need to integrate again for the expected value of y? No, it is the same. If you write down the definition for this case, it is y f xy dx dy. So first write the limits. X goes from 0. Okay, let me explain this. X from here, start from here and stop on this line. Therefore, from this equation, we can have x equal 1 minus y. Therefore, and also y goes from here to minimum is 0 and maximum is 1. Therefore, x goes from 0 to 1 minus y, and y goes from 0 to 1. Actually, if you consider this and this, you know those are very similar. The only different y and x. But according to this, you see the limits are very similar. Therefore, this answer is also 1/3. And you don't have to integrate again. So expected value of xy equal double integrals xy and join PDF and dx dy. So let me explain how to pick the limits. And fxy, our case is 2, therefore 2 times xy. So this case I will use first dy and dx. It doesn't matter, but I prefer to use dy. Why? Because we know y goes from 0 to this. So again we should consider this region. So in this region, y change from 0 to here. So start from 0 and stop. The endpoint is on the axis y equal negative x plus 1. Therefore, I can write the limits from 0 to 1 minus x and x equal, as I explained before, the minimum value is 0 and maximum value is 1. So once you integrate this, you will get 112. Now we know covariance xy equal expected value of xy minus expected value of x and expected value of y. So what is the expected value of xy? 112 minus 1/3 times 1/3. So this equal negative 1 over 36. Now I use this problem to explain the correlation coefficient. So you can read this in our textbook, page number 265. So definition is raw correlation coefficient, covariance y1, y2 divided by variance of y1, variance of y2 and square root. So this is the definition of correlation coefficient. Okay, now how do we find this? Yes, we already know covariance x and xy. So let me write down this definition for our problem. It should be covariance xy divided by variance of x time variance of y and square root. So covariance of xy we know already negative 136. But we need to find the variance of x and variance of y. How do we find the variance of x? So variance of x equal expected value of x to power 2 minus expected value of x whole power 2. We know the expected value of x. It was 1/3. So we know this one. It was 1/3. But we need to find this expected value of x to power 2. How do we find the expected value of x to power 2? Expected value of x to power 2 equal integrate x to power 2 fx x dx. Again, we have a marginal uh, density function. So we need to use joint PDF to find the fxx. So if you use this, what we did before, as we did before, it should be x squared f xy dx, also dy here and dx. Now let me find the limit of for our case. So first y, again y goes from 0 to, you know, now you understand 0 to what? 1 minus x. 1 minus x, and x goes from 0 to 1. So x to power 2 fxy is 2 and dy dx. So this equal 1 over 6. Okay, now we know expected value of x squared, which is 1 over 6. Now we need to find the variance of y. Okay, before we go, I forgot to tell you. Now we know these two values. Let me use the green color. Expected value of x to power 2 is 1 6, and expected value of x was 1/3, then it power 2. So once you simplify this, you will get 118. So this is the variance of x. Then what is the variance of y? Variance of y is the same. Again, how do we find the variance of y? Variance of y equal expected value of y to power 2 minus expected value of y whole thing square. Then you can find the expected value of y to power 2 as we did for the x to power 2. So you will get this answer 1 over 18. The same. Now we can use this row equal this. Let me show you. Row equal negative 136 and 118 times 118 and square root. So this simplify this one, then you will get negative 1/2. So this is the correlation coefficient of x and y. Two independent random variables x and y have normal distributions. Okay, x and y have normal distributions with mean 2 and 3, standard deviations 3 and 5 respectively. The jointness distribution function is given. They are asking to find expected value of x to power 2 y and covariance of xy. So how do we find the expected value of x to power 2 y? if you don't see the conditions we have here, then you will try to find these double integrals x square y f x y dx dy. So if you go in this way, this will be very difficult. And go back to the problem and read it again. It say x and y are independent. They are independent random variable. Therefore, you can write this equation expected value of x to power 2 time expected value of y. Now we can find the expected value of x to power 2 and expected value of y. So what is the expected value of y? Yes, it is 3. It is given. Then what is the expected value of x to power 2? It is not given, but we can find it using this equation. Variance of x equal expected value of x to power 2 minus expected value of x whole square. Standard deviation of x is 3. Therefore, the variance of x is 3 to power 2. Expected value of x to power 2 minus expected value of x is 2, then 2 to power 2. So expected value of x to power 2 equal 9 plus 4 13. We can plug these numbers to this equation. 13 times expected value of y is 3, so 39. Therefore expected value of x to power 2 y equal 39. Then how about covariance xy? Again we know x and y are independent random variables, therefore covariance xy is 0.